Well, hello. I didn't see you there. Thanks for joining us today. We're going to talk about today key features of graphs. What? Key features? Lots of different terms today that we got to know the definitions of. But they're going to be, if I look at a graph, it says, a key feature, like what's the y-intercept? What's a maximum? What's a minimum? So we're going to look at those and try to know how to write them, when to write them, how to know when it's an absolute maximum or just a conditional maximum, like it only happens sometimes, or relative. I should use that word, relative maximum and minimum. We're ready to go. So on page 82, there's a couple things here that start off. It says the graph above, and I don't have anything above, shows data that are continuous. The points in the graph are connected, continuous. Discrete individual points. So let's make a sketch of those. What would a continuous look like? To start off, a continuous is going to be connected. Okay, it doesn't have to be up and down. It could just be a straight line going up. It could be that line going down. It could just be a line going straight across, but it's connected. Now, discrete are ones that just have specific points or dots. Discrete graphs, move that up there, my apologies. Discrete ones are ones that it's like if I am buying something, you can't buy 2.7 shoes, but I could buy 1 shoe, 2 shoes, 3 shoes, 4 shoes, etc. But I can't have anything in between there. So I don't put anything in between there when I graph it. I graph it discretely, which just means point by point. Okay? All right, so we get continuous, discrete. Continuous, it's like the dots are connected. Discrete, they are disjointed. That's another way to think of it. So continuous, connected, discrete, disjointed. Okay? Now, we have other parts then to this as well. So they talk about first absolute maximum and absolute minimum over here where it says connect to AP. You think, I might not need to know that. No, we do. Absolute maximum is the absolute highest a graph goes. So if I go over here, I know I have an arrow here, but let's say I stopped at this point. That's the absolute maximum because that's as high as that graph goes. Absolutely. Okay, now the absolute minimum looks like it would be over here. That's the absolute lowest part that there is. But they talk about, we'll get back to y-intercept, what about relative maxes and relative mins? Well, it's just, if I were to look at a certain chunk of the graph, and I was to say, well, like this is a roller coaster maybe. Okay, and I'm looking from here to here. Well, this would be a relative max. It's a relative high point before you go to a relative minimum point. Here's another relative max, another relative min. Okay, it's relative to the situation. It just depends where exactly it's located. Whereas absolute, that's the absolute highest, that's the absolute lowest, no question about it. Okay. Now, y-intercept is exactly like it sounds. Okay. For math, I always say we don't choose fancy words because we're math teachers. We try to keep our English simple. So y-intercept is where a graph or function intercepts or crosses the y-axis. Okay, so y-axis is the vertical axis. Here is my y-intercept. That's where that graph crosses the y-axis. Okay, that is often an important one because right here, the x is 0. So if I were to write it as a coordinate, it would be always 0, comma, something. I'll put a question mark there, wherever it intersects. Why is that important? Well, as we get to more real world problems, a lot of times they start at that point, at the y-intercept, because it's like saying if I'm selling shoes. Well, what if I sell 0 shoes? Well, there's still a cost to make those shoes, so you might be losing money at 0 shoes. So that's still the y-intercept. At 0 shoes, you're in debt negative $200 because you haven't sold anything. You made the shoes, but you didn't sell them. Then after you sell 1, it goes up and so on, but it's always at 0 for the X value. The Y value could sometimes be 0. It's possible. Maybe I had a discrete one here and there's 0, 0. Okay. 0 shoes sold, $0. Okay. So that's possible as well. All right. So now you know the terminology that goes along with it. Let's look at some graphs. So this graph is just a straight line. Now, the first part we want to go into is what's the domain and range of this function? So now we're going to have domains and ranges that are different than 1, 2, 3, and 5, 7, 8, or whatever they were when we first started talking about domain and range. It is literally impossible to write all the points that are on here because there's an infinite amount. You could have 1.1, 1.11, 1.111, 1.11111, small increments, but you could still write them there. So the domain, though, when I look here is where do my X values start? Well, they start here at 0. Where do they end? Notice I'm not following the graph. I'm following down here and looking at the graph and saying, okay, they end at 200. So my domain consists of the numbers between 0 and 200. Well, how do we write that? Oh, look at that. Inequalities. See, all of this comes back and connects with it to say, okay, the domain is between 0 and 200, including, because I have the or equal to, you could have 0 feet on the track or exactly 200. Okay? Now, the range is going to be very similar to this. I start at 0. Okay, now I'm looking at the y-axis, but I go up to this point here, which if I'm looking, it's going by 25, so that was 150. This would be 175. So my range are the y values. So here I'm going from 0 to 150. Okay, so I'm just looking, what are the possible x values? Well, it could be anywhere from 0 to 200. What are the possible y's? Well, the lowest is 0, the highest is 175. Okay, why is that helpful sometimes? I'm going to skip to 8. Identify the absolute max and min. Well, that's usually where your range starts and ends. So my absolute min, let's go there, is 0. Just going to put it under there. My absolute maximum was the high point, 175. It is not, oh, I wrote it wrong here. I put 150, my apologies. It is not a coincidence that this is your min and this is your max. That will absolute min and max. That will always be the case. All right, what's the y-intercept of this function? Well, where does it cross the y-axis? We know the x value will always be 0. What's the y value? 0. That's also a very good possibility that it could just be 0, 0. Now, for this one, does it have any relative max or min? No, there aren't any. It's not going up and down or curling, something like that. We're saying, oh, there's a relative max, there's a relative min. It's just going, whoops, straight up. It only has an absolute min and an absolute max. Okay? All right. Let's move on to one. Think about this for a second. First, the check your understanding number 11. Is this continuous or discrete? Oh my goodness, that's what they ask. Is the function h continuous? No. Why not? It is disjointed. Continuous means connected. So no. Okay, you could explain by saying it's disjointed. Okay. All right. For number 12, a function has 3 relative maxes, -2, 10.3, and 28. One of the relative maxes is also the absolute max. Which one? Well, which one is absolutely the biggest number here? 28. Okay, so we talked about that. Here's an example of saying, okay, it has relative maxes, but also always has an absolute max as the absolute highest. All right, let's go down to time hiking. The Juniper Loop. The graph shows his distance from starting point. So let's start domain and range. Okay, so domain here. For my domain, I am looking at where do the x's start, where do they end. Now, it just happens they both intersect the x-axis. That will not always be the case. but they do here. So they start at 0 and they go to, these are going up by 15s. Interesting. So 165. Okay, so it's continuous, so it's every number in between there. So I don't have to put something to the side that says, well, it's continuous, but, or it's between 0 and 165, but only whole numbers, because that might happen. In this case, it does not. Now, the range. This is where people get thrown off, because they'll say, oh, well, here's, it goes here and it goes there, so it's 0 to 0. No, 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 no. I need to play that song. No, 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 no. Sounds like, watch out for that tree, like it's a Tarzan one. It might be. I don't know. So here's my lowest y value. I'm looking at the graph and going to the highest y value. The highest point it could be is 7. That is where I get my range from then. To say that the range is from 0 to 7. So 0 is less than or equal to y is less than or equal to 7. Okay. Now, identify the absolute minimum of the function. Well, what's the absolute lowest spot? 0. What does it represent? Well, what is the y value? The distance from the start. So I could jot that down and say, oh, it's just the distance from the beginning point. In the function, I'm going to kind of slide this in here too. Okay. The absolute minimum corresponds to 2 points. Fold this over. On the graph. What are they? Well, I have a minimum point of 0 and a minimum point here of 5. So I have 0 and, whoops, I'm writing 5. I'm going to rewrite that. 0 and 5. Well, what does it mean if he doesn't get any farther at this point? Okay, well, it just means that he probably took a rest. He sat there for a while, from 30 minutes to 60-ish minutes. That's okay. So sometimes we want to think about what it is as well. You know, what's the absolute maximum? It's 7. What does it mean? That's the farthest away he is. Okay. What points correspond to the absolute max? Well, if I'm looking, I have 2 points here, really, but it's this section of points. And what does it mean? Again, if he's not getting any farther away, he probably just took a rest. So it's just getting you to look at and think about what are those different pieces of it and how do they fit in? Maxes, mins, finding your domains, all of those different pieces. Okay. All right. Let's go back here. And I think I might have, looking for a moment. Talk on here. No, I don't know where. I must have skipped a page. Independent and dependent variables, and I did. See, we're going to go to it right now though, because it's okay. So we talked about here, this is the beginning of 6.1. I should have started on 81. However, it's okay. Independent and dependent variables just go to x's and y's, really. The independent variable, x-axis. The dependent variable, y-axis. Why? It depends. How far along are you on the track? Well, that's independent. How high above the ground are you? Well, that depends on how far along you are on the track. So the independent can stand alone. How much money do you make if you sell a certain amount of shoes? Well, you only make so much. It depends on how many shoes you sell. So money is dependent. Independent is the amount of shoes you're selling. The other part they talk about here is the vertical line test. We actually discussed this with functions, but now we could check it too. Vertical line test is just going along and checking. It's a function if it only passes the line through 1 point at every spot on the line. It would not be a function if, say, for example, it like looped around here and then went here. So like if I went here, that does not pass the vertical line test. Okay, it crosses that vertical line at more than 1 point. So that's going back to the vertical line test. So the reason we need to know what they ask, what's the independent and what's the dependent variables? I'm just going to label. The independent is always my x's. The minutes since the bath began. The dependent is the depth of the bath water. Okay? All right, now let's write domain and range. And with these, again, pause first, try to do it yourself. So the domain is where the x's start, 0. Where do the x's end? 12. So 0 is less than or equal to x is less than or equal to 12. It always less than? Yes. We're saying x is between 0 and 12. Now, what about the range? We're looking at the low point is 0. What's the high point for the y values? 8. So it's the same thing, or the same idea, less than or equal to, but I'm going to put a y in there as well. Okay? All right. Going to the next, discrete or continuous. Well, is it disjointed or connected? It's connected. So that's continuous. How do you know? It's connected. What's the y-intercept? Well, where does it cross the y-axis? Right there. So it's 0, 0. What's it mean? It means the bath didn't begin, so there's no water in the bath. How do I know? Well, 0 is x. 0 minutes since it began. 0 is the water, or y is the water, which is 0. So how much is it in depth? 0. It basically didn't start. Okay? Any relative maxes or mins? Not really, no. You know, it has a low point, it has a high point. It doesn't have a couple up and downs. So it has an absolute max, which is 8 inches. Absolute max. And the absolute min is 0 inches of water. Okay, so nothing fancy about it. It's just taking the time to think through, all right, where did I start? Where did I end for domain? Where did I start? Where did I end for the range? Looking at the vertical part. What's the absolute highest? The absolute lowest. Where does it cross the y-axis, the vertical axis? So straightforward, but just take the time to make sure you're thinking through each one of them. Boom, boom. Yes.